So very good morning. So I am currently pursuing my doctorate program, and I am a senior member in IEEE. I wish you all to become a member of IEEE so that we will get updated with what is the current issue which is going on, and even you can, if it is the amount is little bit high in case of IEEE, you can go for ISTE or IEI. Going into some professional body membership is good. Okay, so let us today discuss our power semiconductor device and overview. First of all, let us start with the objective. What is the objective of this subject to be studied? Then the first is power semiconductor device structures adjustable for speed motor control application. So when you say today the topic of research which is going as electric vehicle, so when you say electric vehicle, it is you will have a motor control, so you have to use power electronics based semiconductor devices for controlling your speed of your motor, and for this you should know the structure of the semiconductors. There are different structures there, so that is our first objective. Then you have to understand the static and dynamic characteristics. Whenever say we also have some characteristics, our characteristics is not same all the time, and sometime we will be in static and sometime we will be in dynamic. Static is like normal time, but dynamic is whenever you are in stress or in some other depression or any other aspect, then your characteristics will change. Similarly, semiconductors also has static and dynamic characteristics. So we will see for current control first. There are two types. One is called current control device, another one is called voltage. I will say all this in detail, what is current control, what is voltage control and all. So entire semiconductor, active semiconductor devices, leave about passive. Let us go to active. In case of active semiconductors, you can call it as either current control or voltage control. So we will see all that characteristics. Okay, then for proper selection of devices, this is the major thing. See, you might have designed a converter or inverter circuit. For this, you should not randomly select the device. Device, what we say is semiconductor device. So proper selection has to be done. After this, how you are going to control and how you are going to fire. See, firing for all the devices is not same. Firing is nothing but giving pulse to turn on, or the way by which you turn your devices to on state from off. Okay, so we have to read about how to control and the firing circuit. So this will be the objective of this particular subject. So let us start with unit number 1. So unit number 1 is like an introduction. So in this we will see what and all types of semiconductor devices are available in this unit. Okay, then when you say as an ideal person, see, even you can take as an example. See, I will always try to take example as our creation itself, human creation, because it is, you can gain more and more knowledge from our behavior itself. Okay, we are an 100% efficient embedded system. So our embedded system cannot be reached by whatever the technology may develop. It has to be behind this human creation. So I will always try to compare it with ourselves so that you can understand it clearly. Okay, so attributes of an ideal switch is nothing but it is supposed to say that even if we keep classes from morning 8 to evening 4:30, you have to listen with the same level of what you started with the first hour. This was the ideal case, but this will not happen. As you prolong with unit first hour to second hour, third hour, fourth hour, then automatically your grasping power will come down. And similarly, semiconductor devices also, you say it is a switch, you turn on and turn off, but when you turn on, it will not get turned on at that instant. It may take some time. Similarly, when you switch off, also it may take some time to turn off. So all this we will see. So we will see about symbol. Then power handling capability. This is a new. See, you might have used your semiconductor devices in your UG for around maximum of 30 volts, okay, and a current rating of maximum of 1 amps. Whereas in this subject we will see about current carrying capability of around 300 to 400 amps, which is very high. And when current is increasing and simultaneously if the voltage, then the power rating of the device will increase. So each and every device has its own capability, so you should not cross it. If you cross the level, automatically the device will burn. So you have to clearly understand what is power handling capability. Then device selection. So based upon power handling capability, we will select the device. Then we will see about on state and switching losses. So there are some losses when a switch is turned on, similarly turned off, as well as there is something called power loss. Okay, we will see all that. Then comes your EMI. EMI is electromagnetic interference. This is because of the introduction of power electronics. So after the invention of power electronics, or after bringing all power semiconductor device into your AC line, there was no EMI and there was no THD. Okay, once you bring all this device, so we are the cause for generating the harmonics and the THD. Okay, so only because of ME power electronics and drives. So this is our next part. So we were till we were saying that we were able to get the fixed DC to variable DC, all such things we were saying, but getting on input side there is some disturbance created, and that is EMI and THD we will see. Okay, then comes your power diode. So for power diode we will see forward and reverse characteristics. So this is introduction unit where we go for passive device, that diode. From next unit we will go for active device. So here we see about power diodes forward and reverse characteristics. I will say what is the important. You might have drawn your forward and reverse characteristics for a diode, but I will discuss what is the need for forward and reverse. See, we all say that device conduct in forward direction, so forward is important, but reverse characteristics is more important than forward characteristics. I will let you know so that you can know the importance. Okay, then switching characteristics, how fast it is able to switch and what are the various ratings available. So for various power level there are various types of power devices are available. Okay, so moving into unit number 2, it is called current control device. Current control device is nothing but you will have a base. To that base you try to give electrons from external and you try to turn it on. You might have seen common base, common emitter, common collector, three configurations of BJT. All that we will see. It is controlled by external electron, so that is why we call it as current control device. There is some issue in current control device, that is when you are converting from AC to DC, that is called as rectification operation or rectifier operation. There this current control device will be excellent, which means you can use current control device because automatically your current gets to zero after every 20 milliseconds. So after positive half cycle it will touch zero and again it will go to negative half cycle and then again it will come and touch to zero. So for every 20 milliseconds it goes 2 times across the zero. Okay, so whenever it goes to zero, automatically device will get turned off. So you can use current control device where you are using AC source. Okay, wherever there is a AC you can go for current control, and whenever you go for DC, there like any converters where you convert from one fixed DC to variable DC. Similarly, when you convert from DC to AC, that is inverter operation, where current doesn't come to zero at all, because where in your converter circuit you move from one voltage to another voltage where current will not come to zero. In that case you cannot turn off your device at all. So only we move on to voltage control device. So we will see what is MOSFET and IGBT. So we will see the construction. static. Similarly, in second unit also you will see about its characteristics. Okay, construction characteristics, switching characteristics, then 2 transistor analog, concept of latching, gating and switching characteristics, then comparison, then steady state and dynamic model of BJT, and there are some more current control device which is called as GTO, MCT, FCT and RCT. All this thing we will see in detail. Okay, so these are the various current control devices. Next to this is voltage control. Same thing we will see. For voltage control device we will see the construction, switching characteristics, steady state and intelligent power modules. Okay, power modules are nothing but how we are going to turn on integrated gate commutated thyristors. It is one more type of voltage control device. And then we will go for comparison of all power devices. So this is about unit number 3. And unit number 4 we will see about firing and protecting circuits. Okay, there is a need for isolation. See, in your electronic device lab, you may give firing pulse from any microcontroller to your device, and the device may be operated in 10 volts or 5 volts. Whereas in our case, now we are going to operate, let us take, I think you all know MOSFET. So MOSFET is a 3-terminal device. You have drain, source and gate. You give a pulse to gate and actual supply is applied across drain to source, and that value will be very high in order of voltage. If you say it will be around 200 or 230 volt, even 400 volts. If there is any leakage in this, it will be transferred to the source side. Source is nothing but your gate. So automatically gate will be unable to withstand this very high because it has been connected to microcontroller whose power supply is only 5 volt. So the entire circuit will get collapsed. So that what is required is there is an isolation required between your pulse and your drive circuit. Okay, so we will go for pulse transformer is one type of isolation. Then we will go for optocoupler. From the word itself it's very clear, opto means light. With the help of light you are able to coupling the circuit, and from the input side to output side you can have a light control, and from output side there won't be any light flow, so it is only unidirectional. Then comes gate drives. Gate drive is nothing but, we all know that at a particular value only the device will get turned on, and that power level I cannot produce from microcontrollers. So I should have an in-between person who is called driver. See, again I will say, if you want to travel from Chennai to Tirupati or Chennai to some place, you can walk, but you cannot walk from Chennai to Tirupati. So what you do, you take a bus. So what is the role of the bus? It is called a driver. Okay, which means it is driving you from Chennai to Tirupati. Okay, so similar way your pulse is there, and the pulse level will be only 5 volts from the microcontroller, which is not sufficient to turn on the MOSFET. See, 5 volt from a microcontroller will have a pulse magnitude of 5 volt, but I think you all know that MOSFET, you have a minimum gate turn on voltage. We call it as VGTH, that is minimum gate turn on voltage, which is around 8 volts or in some case even 12 volt. So how to make this 8 to 12? You should have a driver. So this fellow will try to increase and try to provide it to MOSFET, and so all such things. So IGBT also we will see, like MOSFET similar to IGBT we will see. Then we will try to see what is over voltage, over current and gate protection. Over voltage will occur in a circuit. So when suddenly if you turn on and turn off, when you suddenly turn off, what happens? Current comes to 0 and voltage goes to its maximum value. But if we have done suddenly, so voltage will go to 5 times of its value. This 5 times value voltage if comes across your device, you might have not designed for that very high voltage, so automatically your device will break down. So how to look into over voltage? Similarly, when you suddenly turn on, in that case voltage has to come to 0 and current has to increase. And since you are doing at very high switching frequency, we all know for MOSFETs we will give 25 kilohertz or 30 kilohertz or 50 kilohertz. So it is very high switching frequency. So that very high switching frequency leads to similar when you do for when the condition for turn off. Similarly for turn on, now current will go for a very 5 times of its value. and this also leads to failure of the device, so you have to protect. And the last one is gate protection, that is by proper isolation. Then there is a called a snubber device. So with the help of snubber only we are able to protect from high voltage and high current. We will see what is a snubber and all. Then comes your fifth unit. We all know that what we are using is not a conductor nor an insulator, so it is a semi person. So obviously some amount of electron will be converted as heat. See, if the path is very clear, for example, you create a channel for your water flow via an marble flooring. So if there is marble flooring and if you pour water at one end, the water will try to flow to other end and no waterlogging will be there and all water will try to reach. So this is the case when the surface is so smooth. Okay, so usually it is in conductors, whereas when you take semiconductor, it has its own resistance, so it will try to offer resistance to the flow of electron. This resistance will be converted in form of heat. Electron will be converted into heat energy. So you have to remove this heat energy from the device, otherwise the device will leads to thermal runaway problem, and thermal runaway is nothing but constantly increasing in temperature in semiconductors, thereby the entire device gets failed. So that is what we will see in unit number 3. Okay, first one is heat transfer. I think we all might have seen motherboard of your computer. There is an fan over it, motherboard, above the processor, that is to transfer the heat from the processor. There is 3 ways. One is called conduction, another one is convection, and third one is radiation. Conduction is placing some other metal on the top without any air gap. Then the heat from the processor or heat from the semiconductor will travel by the process of conduction. Okay, convection is between the two different metal, and radiation is from metal to air. Okay, so that is why when you see above processor there will be some fins like structure and fan. So fins is for conduction and convection, and fan is for radiation. Okay, so different types of cooling we will see, like liquid cooling, wafer phase cooling, and all this cooling you might have not seen. You might have only seen with an heat sink. Now we will see what is liquid cooling and all. Example for liquid cooling is, you can go to Google and try to see server of Google. Server of Google is kept in Bangalore, where think of a single processor is being used by all over the world. See, when you type www.google.com, you go to the server of Google, so you are trying to use your processor there. So automatically, if more and more people is operating, then it will get eaten up. There they will go for liquid cooling, even like very low temperature they will try to maintain, so that the processor is not get eaten up. And there are something like vapor and phase cooling and all, we will see them. Okay, then comes your heat sink. So heat sink, you might have seen a black like structure which is kept behind your semiconductor devices. Then we will see about thermal resistance. Current will flow only through minimum resistance. Similarly, heat will also flow through minimum resistance. So you bring an heat sink with some material which has more resistance, then heat from your semiconductor will not get transferred to heat sink. Then whatever you done is waste. Okay, that is why heat sinks are provided using metal. So because metal have less resistance for thermal. Okay, then electrical analog for thermal component we will see. Then we will see different types of heat sinks and different types of mounting and switching loss calculation for power devices. So with this an overview for our subject we have seen. So I will repeat. You start with the introduction, then you go for current control device. There is some shortcomings in current control device, which means you cannot use it for some application. So we will go for voltage control. Then we will see about in Fourth unit like firing and protection. So how you are going to turn on your current control and voltage control device is unit number 4. And unit number 5 is your how to go for thermal. So this entire subject is only how you are going to select a particular device. Okay, so it is not that all device will not work for all circuits. So for each and every circuit that device will vary. Similarly their power handling will vary and proper selection has to be done. If this has not been done, your circuit may be good but your device will not work. Okay, so this subject is very important for power electronics, because in other subjects you will read the circuit for a converter, where you say for a converter you need a switch. There you will not see about switch, you will design about inductor, capacitor and all, but we should know how you have to select that switch. So that is this subject is. So with this